Good morning. My name is Anushka Pise. Today we are going to learn a topic from the chapter Acids, Bases and Salts. Acids, bases and salts is one of the classification in chemistry. But the question arises, why do we need a classification? I would like to give an example. Imagine a cupboard which is piled up with clothes. It makes difficult for us to choose the right cloth for the right occasion. Same is with chemistry. If the cupboard of chemistry is organized properly, it makes easier for the scientists and students to study the properties of elements. Now we will see one of the classification that we have studied in 9th standard. Classification of matter. Matter is classified into elements, mixtures, compounds, and they are further classified. So we'll see what is matter. Matter is a substance that has mass and occupies space. Then matter is classified into elements. Elements are the pure substances which cannot be broken down further. Example of it would be oxygen, hydrogen, sodium, and many more. Mixtures. Mixtures are made up of two or more substances combined physically. The word physically is most important because we get confused, either they are combined chemically or physically. Then mixtures are further classified into homogeneous and heterogeneous. Homogeneous mixtures are substances combined in same proportions. Example would be air. Then next up is heterogeneous mixture. Heterogeneous mixture are the vice versa of homogeneous mixture. Heterogeneous mixture do not have a uniform composition. So example of it would be milk. Then next up is compounds. Compounds are the substances that are composed of identical molecules. Examples of compounds would be covalent compounds, ionic compounds, and many more. Ionic compounds are held by ions and they are held by a strong electrostatic force of attraction. The example of ionic compounds would be NaCl, MgCl2, and many more like CaO. Then covalent compounds. Covalent compounds have the sharing of atoms between them like H2, N2, O2. Here the atoms are shared between the two hydrogens, two nitrogen and two oxygen. Then we know that states of matter. There are 5 states of matter, but usually we are familiar with the 3 of them, that is solids, liquids and gases. Suspensions and colloids is the example of heterogeneous mixture and solution is an example of homogeneous mixture. In this chapter, we are going to seek answers to some of the questions. That would be why lemons are sour, why soaps are slippery, is Coca-Cola really good for our health, then what is happening to the Taj Mahal in the upcoming years, then what do we use in the cleaning of our floors, that is we use bases. Then again, what has happened to the Statue of Liberty, why its color has changed from years. Then again, are all acids corrosive, is amino acids corrosive, and many more. If we enter into our kitchen, we would be bombarded by acids like the citrus acid in lemon, then oxalic acid in tomato, tartaric acid in tamarind. Vinegar has acetic acid which contains 5% of acetic acid. Then about bases, the toothpaste that we use daily is an example of base, shampoo, then antacids and many more. So we'll see what really acids are. Acids are those substances that give H plus ions in an aqueous solution. But first, we'll see what is H plus ions. H plus ions. So, we have seen in the last grade that atoms can attain stability by three conditions, either by sharing, donating or gaining. First, we'll see sharing. We can take an example of hydrogen because it has the atomic number of 1, H. It has one electron in its outermost shell, that is 1. It needs 2 electrons, so it will combine with one of the hydrogen and both of them will have 2 electrons. So now they are stable, forming H2. In the same way, atoms can donate their electrons. Here the example would be sodium. Sodium has the electronic configuration of 281. It has excess of 1 electron. So it will give it to some or the other element that needs 1 electron. Like the example would be chlorine. Chlorine has the electronic configuration of 287. So it needs 1 electron to complete its octet. So after gaining electron from sodium, it will form 288 and will be stable. Our parents are always like we should donate things. Donating is a positive thing. So sodium has acquired a positive charge after donating, and I won't say that gaining is something negative, but yeah, of course positive is taken, so their left is negative charge. So chlorine has acquired a negative charge. So donating is done, and then next is gaining. That the electron from sodium has gained by chlorine, and they have formed NaCl, which is an example of ionic compound, and this H2 is an example of covalent compound. So we have got that H plus ions are given by acids in an aqueous solution. Then what is the condition with bases? Bases give OH minus ions in an aqueous solution. So what are the examples of acids? It would be HCl. And what are the examples of bases? Would be NaOH. When they are split, we found that H plus and Cl minus. Here the H plus ions, that is H plus ions that are given by acids. And in the same fashion, Na plus and OH minus. So same way it is a base as is giving OH minus ions. So now I would like to tell you about the indicators. But before moving, we humans have 5 sensory organs, but these organs fail when it comes to determine a substance that is an acid or a base, because we cannot use our skin, that is we cannot put acid because it may burn our skin. Same is with the case of tongue. So by seeing also we cannot determine something is acidic or basic. So to our rescue comes the indicators. Indicators are the substances that give out show a chemical change in them and give out a color so that we can determine that they are acidic or a basic. So indicators are of 2 types. One of them is natural and the second one would be synthetic. In natural, it's come to turmeric, then next would be red cabbage, and in synthetic indicators there is phenophthalene, litmus paper, methyl orange, and many more. So I would like to suggest an experiment. Take a tablespoon of turmeric and add water to it. The color of it would be yellow. If we squeeze a a lemon, then its color would change to red. And it's not a magic, it's the magic of the acids itself. Same way, if our clothes get stained up with turmeric, then after washing it with a detergent, its color would change to red. So we can get that turmeric is one of the indicator, and that is a natural indicator. Moving towards phenolphthalein. Phenolphthalein is obtained by organic molecules of carbon, hydrogen and oxygen. It was first used by Adolf Bayer in 1871. Phenolphthalein in acidic medium remains of the same color, that is, it is colorless in acids, but in bases it changes its color to pink. What about litmus paper? Litmus paper is obtained by lichens, which is the group of plants of symbiotic relationship that show them. So, in litmus paper solution, in acidic medium, it shows, it turns blue litmus to red, and in a basic medium, it turns red to blue. So, we can get to know that B for bases, B for blue. So we can remember it by B for bases and B for blue. And same is with acids. But when an acid is determined by a red litmus paper, it do not show any change. And same is with bases. When we react it with blue litmus paper, it does not show any change. Then next comes up with methyl orange. Methyl orange is obtained by sodium nitrate and by adding to it sulfonic acid. Methyl orange changes its color to red in an acidic medium and to yellow in a basic medium. Then next comes up the olfactory indicators. Olfactory indicators are the indicators that show the change in their smell. Example of which would be orange. Now, I remember that I put forward a question to you that the color of the Statue of Liberty has changed over years. When France gifted it to USA, its color was brown, and now its color has changed to green. This is due to the reactions in the atmosphere, but we can use HCl to do that, as the Statue of Liberty is made of 300 copper plates, but the HCl, that is an acid, cannot be used in this purpose. I want you to brainstorm yourself and think over it. Thank you.